All right, well, thank you very much for the opportunity to speak. I'm going to have my assistant, baby Claire, sitting in on this video, but I'm excited about the coding in high school physics section. That's something that's been a passion of mine for many years. So before I get into the STEM coding object tracker, which does involve a little bit of coding, I want to just give an overview of the STEM coding project, which is led by myself and Professor Rochelle Teeling-Smith at the University of Mount Union. So in a nutshell, this is what we think is appropriate for high school physics and physical science. So in this game, which is styled after the classic asteroids game, initially the ship can only move in one dimension, and the student has to modify the code to get it to go in multiple dimensions, and to get it to rotate and spin, things like that. So this is a nice activity because we can show the vectors, we can reinforce vector knowledge, we can let the students change the mass of the ship to learn more about inertia, conceptual physics, that sort of a thing. And we're really good at making the code for this something the students can actually digest. The code isn't like horrendously complicated. So in a nutshell, this is what we think is appropriate in a high school physics classroom. And kind of our contribution to the discussion of what deserves to be in high school physics is that you shouldn't just code stuff up, press play, and watch it go. Often you can interact with it, and there's something to be gained from that interaction. So that's kind of been our message for quite a while. So we've been making physics of video games activities for quite a while. So these are some of the ones that we've done. We like to post them on Hour of Code and also on YouTube. So in this game, there's a little circle that moves to the right when you press the right arrow, but when you push the other arrows, it doesn't do anything. So for example, press left arrow, it says do nothing, so students have to change that. They have to make sure that both the X and the Y are getting updated, those sorts of things. So I hope this shows you that this is the kind of code that we think, we designed this activity specifically for 9th grade. So it really is simple enough for high school students to do. So there's all sorts of fun stuff that we've made over the years. Pong has really good elastic collisions in it. We've also made some things based on escape velocity to celebrate the image of the black hole in 2019. So at this point we just have a ton of different activities that are on either Hour of Code or on our YouTube channel. On some level the YouTube channel is for teachers as much as it's for students. But one of the things we're really proud of is that we frequently feature women and underrepresented groups on our YouTube channel, so that students at home can see people who look like them coding, learning about physics, and having fun. So please check out our YouTube channel when you get a chance. And then we also have a summer course that we're running now. It might not be too late to join the part 2 of it, but each summer we do, in partnership with American Association of Physics Teachers, we do an online training for both physics and physical science teachers, so we combine that. And so we have an absolute beginner course, so if you haven't programmed at all, we can work with you. And then there's an intermediate course as well during the summer, and which we hope is affordably priced for you. You do get grad credit for completing it, by the way. So if you want to learn more about basic overview of STEM coding project, you can click that link. All right, now for the STEM coding object tracker. So last year, Rochelle and I published a paper in the physics teacher called Computational Thinking and Introductory Physics. It's a very philosophical paper. It was kind of asking, like, what is the goal of doing coding in high school physics and physical science? Like, what ultimately, philosophically, are we trying to do? And a paper that everyone should read on that subject is that kind of we draw upon heavily in our paper is David Weintraub's study of computational thinking. And in that paper they identify 4 different computational thinking practices, of which working with data here is one of the most important. And it's actually in the paper, if you read the paper, it's even more important than this sort of figure from the paper suggests, and other people agree with us in that interpretation. And so I got to thinking, I was like, how can STEM coding, which has been a lot of physics of video games, not so much data analysis, how can we incorporate more data analysis? And so I started to realize that, well, we need to do more stuff with experiments and analyzing videos and that sort of thing. So I played around with the different softwares that are available, and I found that basically only 2 had object tracking. Now, for a long time, Tracker Video is not available on Chromebooks. Just in the last year, they've released a version that is, which is great for them. When I did object tracking, I found that it was difficult, and I'm going to tell you about an approach that I think is easier. But when you're in Tracker Video, so this is from Brian Lane's Let's Code Physics YouTube channel, which is another thing you should check out. Hey, Brian. So he has a red post-it note on his shirt, and he's walking across the sidewalk, and he's trying to track himself with Tracker Video, and it works fine. The way that Tracker does it is that they have a template image that it's trying to track. So there's this complicated scene, and Tracker is trying to locate this sort of red post-it note. When I tried to do this sort of a thing, it tends not to work very well for me. And so I came up with something that I thought was a bit easier. And the thing that I realized is that a much simpler image processing problem is a green ball in front of a black background, or maybe an orange-red basketball in front of a green screen. It's much easier to track objects when you have a solid colored background than when you have something like this. And on YouTube, I see a lot of videos of people using Tracker with these complicated backgrounds, and often it will work, but maybe it takes some tinkering for it to work sometimes. So something that I think, so here's kind of allow me to demonstrate what we came up with, is that, so there's a code here, and there's a video of an experiment, and I can configure the code to track all the red pixels. So this is RGB value, so red and then 0, 0. And then I can tell it the background is green, so I can say 0, 255, 0 for green. And as you can see, this works quite well, except a little bit because the person's hand has a little bit of red in it. But if you know that, you can design the experiment to remove that effect. So this actually works, and you can download the data, so on and so forth. Well, that was a pretty simple example, and it's an interesting one. You can use that to measure gravity and things like that. A slightly more complicated example is this situation where you have a ball rolling down off of a countertop, and so it's moving in 2 dimensions. And so let me sort of open this up. This video is a little bit more complicated than the other one, primarily because the ball is not bright green. So the ball is pretty dark green. I don't know if you can see that. So do you see the ball falling down there? It still works. So, but I had to be careful to specify kind of a dark greenish color for it to look for in terms of the object color. And so there's a simple way to do that. So there's a nice website called imagecolorpicker.com, and you can sort of pick out the pixels and see, okay, this is sort of a dark green, and then you put that in the program, and it seems to work pretty well. The data that you get, it looks pretty linear, as you would expect. So this column here is the y velocity, and when I plot that out, I get a nice linear graph, except for the end, because the ball sort of goes below the screen or goes outside the area there. So in summary, stop tracking objects and start tracking colors, and this is something that can help regardless what tracking software that you're trying to use. It's really important to have a precise auto tracking feature, because it helps you in situations where the acceleration is changing. So for example, air drag. So in air drag, you start off with 9.8 meters per second squared, but it becomes less and less and less until it becomes 0. There's a whole bunch of situations where the acceleration would be changing, but it turns out to be really hard to do that with tracker software, unless you have a really good object tracker. So this is, hopefully this advice can benefit everyone that's using object tracking. So here's my email and some details and links to things. If I have some extra time, I want to talk about, so this is another feature of our object tracker, and the cool thing is that you can specify multiple object colors and multiple background colors, and that's an important thing to do because you remember the video earlier. The person's hand was getting picked up as red, but if you specify that the object color is a couple of different colors, and then specify that flesh color is part of the background, you can get the program to ignore the person's hand. And you can even specify that the floor here is part of the background, and so you can track the ball even when it goes below the green screen. So that's just kind of a nice another feature that's worth mentioning about the object tracker. So, all right, thanks for your attention. Thanks, baby Claire. Mwah.